Hello, everybody. Thank you for joining my presentation today. My name is Chris Colosimo. I'm the product manager for Parasoft, focusing on API testing and service virtualization. Just wanted to get up here before we started into the presentation to let you know what this is about. This is based on a series of observations that I made as I was working with a large series of enterprise customers deploying API testing solutions. So I wanted to take you through how to use some of that information to then evaluate your decision when it came to choosing an API testing solution. All right, so let's go ahead and get started. So today I'm going to be talking to you about how to deliver high quality software with the right automated testing solution. So before we start talking about solutions and tools, let's talk about testing strategies in general. At Parasoft, we believe in identifying the proper testing strategy up front. We really strongly align with the test pyramid. The test pyramid is all about what types of test cases you should be building and at what layers of your application stack you should be building those. You can see here that it really starts with establishing broad coverage of tests like API tests, unit tests, really low-level granular tests that test against the application code itself or against the exposed API endpoints. These types of tests you should be building the most of because they run quickly, they're easy to diagnose if a defect is found, they're easy to run in automation. Obviously, they require some technical skills, but we'll talk about that. At the same time, though, you should be focusing on minimizing the complex and time-consuming late cycle end-to-end testing that you achieve through manual testing and automated UI testing. Now, that's not to say that you should eliminate manual testing. I hear this every now and then with blogs. Move away from manual testing, go into purely automated testing. You have to have manual testing. The manual testers are the stewards of customer quality. But what it's about is really building your testing strategy in this way so that you have a minimal set of those manual tests, and then you have test automation that then backs that up for regression testing purposes to verify on an ongoing basis that your applications have high quality. Now, there's actually a missing layer here at the bottom, which is static code analysis. Static code analysis, you think of like spell checking an application, or spell checking a Word doc. But instead of, in Microsoft Word, you're actually checking the code to look for patterns that lead to defects, bad practice, things like that. And really, that's your first line of defense, because as soon as that first line of code is written, you're analyzing that on code check-in. Now, let's talk about API testing. So what is an API? I like to think about an API in the same way that you think about plumbing in a house, right? So if your application is your whole house, the interfaces between the different appliances that you have, those are your APIs. It's that agreed upon communication layer that gets the water from the street into the house, right? And when you want to grab some hot water from the hot water heater and deliver it to a sink, this communication behind the scenes really is how the APIs are functioning. And when it comes to automated testing, if you want to test the sink, you don't build the whole house. What you really do is you hook up the sink to the appropriate water mechanism, turn it on, and you verify, okay, this is actually delivering water at the appropriate pressure. And so this is the same thing inside of our applications, right? We don't want to build the whole application before we start testing it. We want to test these interfaces so that we know that if, for example, somebody flushes the toilet, that somebody doesn't get burned while they're taking a shower. Okay, so if automated API testing is so great, why don't we see a ton of people doing it? And the reality is that there are a series of pros and cons. So as I've stated before, API testing is one of the most maintainable mechanisms for test automation because you're not dealing with UIs and you're not dealing with all of the components that make up those front-end UIs. You have the machine-to-machine communication, and you can create tests to drive calls against those backends, against those systems, and then validate the responses that come back. this is a great way to communicate between dev and test. What we've identified is in most automated UI testing scenarios, about 60% of the defects that end up being found in those UI tests are actually being presented at the data layer, at those backend APIs. And so this is really interesting. If I can then create an API test against that, then what I'm doing is I'm actually finding that information earlier, and I'm actually giving the API test to development, which they can then run, and it's pretty close to the code, so they can then reduce the time that it takes to find that defect, which is that last one, the reduced time to remediation, or the amount of time that it takes between when I find something and when it's remediated. But again, what are the challenges here? Testers often don't know how to test the API or how to get the information about what APIs are being used in a specific use case. And that's because typically there's a service definition that's provided, but it doesn't really give you information about how to chain those sequences together. It also requires specialized skills and tools to get the high level of coverage that you need against those APIs. What if you're doing something like REST on one part of the application, but you have some sort of asynchronous microservice protocol like RabbitMQ in the backend? How do you bring that all together? Tools are usually required for that. And then there's this concept of no man's land. We did a survey of testers and developers, and we asked them who does the API testing. And what we found was that something like 50% of the testers were saying, well, no, it's development's job. They create the API, they should then know and create a test against that. But then we found that 60% of the developers were saying, no, it's QA's job. It's publicly available. We have a service definition, create a test against it. Now, we know that both of these roles have different responsibilities when it comes to testing, but that's, I think, why we see it. API testing is a solution for the cost associated with automated testing, but it has these technical barriers. So what we typically see is that organizations go through this maturity process when it comes to selecting automated tooling. They first start by developing an internal solution. Now, these are great because it does exactly what your organization needs. You can build it for the technologies that you have, and you can leave everything else out. As I said, it's good because you can target those specific use cases and build in the automation and the reports that integrate with your systems. The challenge is that the technology is constantly evolving. And so then the organization becomes beholden to that solution. And every time there's a change or they want to add something, they have to make the modification to the code, which is just not scalable. So we see organizations then move to open source or free solutions. And I'm a big fan of open source and free. We're going to talk about that when we talk about tool selection. Obviously, the big pro here is it's free. And a lot of these open source and free solutions, they do a lot. The problem is that free isn't always free for the long term. You're locked into that specific solution, and if it doesn't exactly do everything that you need or it doesn't change or adapt, you either have to add to the original source, which now you're back up to the internal tooling problem, or you have to use multiple tools, which creates fragmentation across the organization. So when organizations seek to solve this challenge, they move into commercial solutions. These are great because they're built for API testing. They're built for modern, orchestrated or reactive environments. They have all these technologies. They have all these cool capabilities, but obviously it's not free. And so it requires an investment. So you have to really understand the ROI associated with it. So what tooling solutions are out there? So I say it breaking down into these two areas. You've got your lightweight tools. A great example here is Postman. Postman's free. Postman does a lot. Postman has a browser-based component. It's great for developers who are doing simple testing against REST JSON or potentially SOAP services. And it is free in the short term until you start thinking about things like automation. But it's an absolutely great place to get started. Then on the enterprise side, you have things like SOAP UI Pro, which are great. And as I said, vendor supported. They have all that technology. But they have a big price tag that comes with them. The real answer is that you need the best of both. And it really comes down to the features and capabilities that you have to have in your solution. Now, this is a bit of an eye chart, and I apologize, but really I think the features and capabilities that you need when selecting a tool break down into these categories. Number one, ease of use and capability. You already have this technical challenge when it comes to the API testing. You need to make sure that the tool itself is easy to use. And I know it's a little ambiguous, but these are the things that I think. I like the idea of codeless, low code, where you're building API tests by drag and dropping interfaces and drawing things or stitching things together like Legos. You want to be able to have an extensibility framework on top of that. So if it doesn't exactly do what you want, you can modify it in the way that you need. You want things like automated assertions and validations. You want to be able to data drive tests with multiple data sources. You need to have test reusability. That means I want to be able to build something in one area and then use that in other areas of my API testing. You need to be able to build tests before the service is available. Now, this could be against the service definition, but you also might want to build those from scratch by stitching together the transport, the message, any authentication that's required, so that you can be ready for that as soon as those APIs are ready. And of course, that then covers the last piece here, which is authentication. You need to be able to support all of the modern standards. Now, that's great. That's the basic stuff, but then you want to think about optimized workflows. You know, most organizations have thousands, if not tens of thousands of APIs. We want to build tests against all of those. And hand stitching tests one by one can be really challenging. So that reusability comes in, but you need to have optimized workflows so that you can build those things as quickly as possible and modify them for the new APIs. This is where things like test flow logic become important. This is the idea that a test can change the way that it's testing and go different directions or call different APIs depending upon what happens while it's testing. You want to have AI-powered test creation. And I know AI is such a buzzword, but there are some serious applications of it when it comes to API testing, such as the ability to stitch together a series of API calls and identify the patterns and relationships. We'll dig into that specifically. You need test data management and generation because test data becomes one of the most important pieces of getting information from APIs. But we can't use sensitive data, or maybe we don't have the data. And so test data generation is a critical component. You want to have things like BDD and Cucumber support so that not only your technical testers, but your business analysts can do your API testing. Here's a quick list of supported technologies, but the reality is that you need a large array of message formats and protocols. I think these are the bare minimum that your testing tool should have, but again, it'll change depending upon your industry. Automation. Your API testing tool needs to be able to run unmanned and needs to be able to make decisions while it's testing. You need it to be able to run from the command line as well as via APIs so that you can integrate it with your cloud solutions. And a big plus is if it has built-in plugins for things like Azure DevOps and Jenkins. And then finally, you need to be able to own this thing. So you need systems so that it can integrate into your existing requirements management systems like ALM or Jira. But it also needs to have things that allow you to orchestrate tests, execute tests, understand the reports in a meaningful way, and then be deployable both on-premise and up in the cloud. And most importantly, it needs to have a change management process. We'll really dig into it. Okay, big list. Sorry, lots of words there. But in my experience, these are the must-haves for your API testing solution. But in order to really move your API testing solution forward, I think there are 4 critical enablers that your solution must have. Number 1, rapid test creation. This is critical because, as I said, API usage is just growing every single day. And you need those testers to be able to lightning quick create the right API tests. Breadth of technology. I guarantee you right now somebody is developing a brand new message format and protocol we've never heard of, but it's going to be awesome. And in 6 months' time, everybody's going to be talking about it. So your solution needs to not only support all of the industry standards that exist now across legacy systems and modern systems, but needs to have a mechanism where you can incorporate or add new technologies as needed. Broadly accessible architecture. I feel like this is becoming more and more important. And this, especially when you think about things like remote work environments, you need to be able to access the solution both as a desktop tool, as a cloud tool, as a headless server tool. Like, it needs to be able to do all those things because you're going to want it deployed at different parts of the API testing process. The creation maybe is on the desktop or in the cloud. Then the execution is actually done as a part of a pipeline. That architecture needs to be easy, flexible, containerized. And then finally, change management. A lot of these solutions fall apart when it comes to change management. So the solution that you choose needs to have a mechanism to not only apprise you of change, but give you direction. Like, how do I fix that? How do I move forward in a meaningful or quick way? So let's dive into each one of these. Let's start with rapid test creation. So I'm going to do this in sort of a series of use cases. So we had a partner that we were, a customer that we were working with, and they were adding some new functionality into their application, and it was integrating with some new APIs from a organization that they acquired. And so they tasked the testers with testing the application from an API perspective. And they said, okay, but the challenge was they knew the UI, but they didn't know how the APIs were actually constructing that information into the front end. And you can think of it like this. It's a series of puzzle pieces that then get spread out across your internal, external, and third-party or partner APIs. Now, once that UI is stripped away, the puzzle pieces kind of look like this. And this wouldn't be a very fun puzzle to put together. How do I know which ones to test? How do I know what sequences to invoke them in? And so this was the real challenge. How do we test this? And so there was a lot of time going back and forth with both people inside of the organization and people in these partner organizations, and it was a very slow to adopt testing practice. Using a solution like Parasoft SOAtest, they were able to cut the test creation challenge in half using something called the Smart API Test Generator. The Smart API Test Generator is an AI-powered solution that monitors the traffic between the front end and those APIs. It then uses AI to then reconstruct the API sequence, telling you these were the APIs that were called from wherever, both public, private, and hidden APIs. This is the sequence, but the AI takes it to the next level because the AI then says, I also saw this data being exchanged between the different test steps. From that, the testers can then move away from the UI and start using those APIs directly against those backend systems, thus cutting the API test creation and understanding time down significantly. And when you're choosing an API testing solution, I do recommend asking this question. What if I don't know how the APIs work? What if I don't know how they're all connected to each other? You know, what mechanisms do we have to put that together? All right, well, let's talk about the second topic here, breadth of technology. So one of the major challenges that I see when organizations are adopting a testing solution is that they'll take an inventory of the message formats and protocols that they have now, and then they'll say, all right, I need to make sure that the testing tool covers these technologies. And then, like I said a couple minutes ago, it all changes after the solution is purchased. Now, there's two problems here. One is, if I then end up having to purchase multiple solutions to solve these problems, then I have a high cost of training my individuals how to use each one of the different tool sets and how to understand how those different technologies come together. The other piece is, well, let's say I want to keep the tool set that I have, but I want to build this new technology into it. A lot of the time you'll get answers like, well, there's a library and you can add this library into your solution. But here's the problem. I have to understand the library. I'm a tester. Am I supposed to understand, 200 plus message formats and protocols? Maybe that might be something I aspire to down the line, but I have to build tests now. And so you want to look for a solution that does that for you. That release after release is looking for those new technologies, those new mechanisms, new authentication, and building it into the solution, or making an actual easy to integrate system, such as a marketplace, that allows you to add those technologies. This will reduce the ongoing training cost because you can focus on, hey, learn how to use the tool, and then the technologies will plug and play in an abstract way. And the final piece here is in being able to then interpret the results and the integration between multiple tool sets. So if I do have something existing that I actually like and I do want to use, to integrate it into what I'm actually building. Things like these open source solutions that I really like: Appium, Selenium, Postman. Should work with whatever tool you're choosing. Now again, you know this presentation is being done by Parasoft, so that's the solution that I'm going to talk you through. But here's how we approach the problem. We support over 120 message formats and protocols, all the way across your mobile interfaces, your web interfaces, really focusing on those API interfaces, but also thinking about things like databases, right? And your JMS or your MQ systems. Not only being able to communicate with those, but being able to stitch them together into an omni-channel test that spans multiple technologies at once. We create a unified test ecosystem, not just a collection of tools, but actually a workflow on your desktop or in the cloud that allows you to build these and stitch them together, all from one individual solution. And with that, can really crack the nut when it comes to breadth of technology and the number of interfaces that you're going to cover. All right, broadly accessible architecture. So here's the challenge. It's 2021. Everybody's working remote. People have really high expectations of how they interact with software. You have the web folks who want to be able to interact with the solution via the web. You know, think things like SharePoint, Teams. They have that web component because I want to be able to, interact with it that way. And it's like a lightweight thing. I don't want to get deep and heavy into the solution. But when it comes to API testing, you're also going to have the folks that want the hardcore toolbox on their desktop, where they can spread out and do all the really complex types of things. The challenge here is that you need a solution that covers both of these, but not individually. These need to be connected so that what the people are building in the web and what the people are building in the desktop have a cohesive workflow or an environment that allows you to aggregate those tests in a centralized location. That way people are free to do what they want. If they want to do the web, they can. If they want to do the desktop, they can. And they can seamlessly move back and forth. But you need an orchestration layer that allows you to make sure that all those test cases are easily categorized, easily searchable, and easily runnable. The other benefit that you get from an architecture like this is the ability to then run tests on demand in cloud solutions like Azure DevOps or Amazon EC2, because the central hub provides the orchestration layer, and this would promote more individuals building tests, handing off knowledge about how tests were built, so that wasn't the kind of situation where, oh, well, Bob built it and then Bob left and we have no idea where the test case is. So Parasoft solves this through the Parasoft Continuous Testing Platform and source control. So the Parasoft Continuous Testing Platform presents as both a desktop and a cloud version of the solution that allows you to use the browser for infrequent or Postman-like testing, while at the same time using that desktop so that you can build, go beyond the simple stuff. Commit the artifacts into source control so that they show up in multiple locations, and you have this centralized repository of test artifacts that are ready for all teams, and a place to then really execute that test orchestration. All right, let's talk about one. This one's really important to me. I spent a large part of my career in the professional services team, really working directly with customers. And I got to tell you, the test creation part, that's the part we first think about. And you'd spend a fair bit of time getting those tests created. But people are smart. They know how to use solutions, and they'll build great test cases. But the big cost with using an API testing solution is the day-to-day aspect of change. So I'm going to tell you a story. I was with an organization, and they were building an application that had both like a web component and a mobile component. both of them communicated with a third-party service, and that third-party service, provided an API to them that they aggregated data from for their application. Now, this service was critical, and so they would run tests against that service. And every now and then, the partner would say, hey, surprise, we're going to be releasing a new version. And business got burned so many times because they would make code change based on, the document or the roadmap, whatever. And in some cases, the third party would say, oh, here's a WSDL. And it's nice. But those changes wouldn't ultimately be reflected in the application. It wouldn't work exactly the way that they wanted. So the business made the decision, you know what? When change is announced, we're actually going to step back from this application for 2 to 6 weeks sometimes. Allow the new version to drop, and then we'll start developing against the system. And this, as you can see, would clearly slow down application time. And I'm sure that 2 to 6 weeks probably sounds a little aggressive, but the reality is you've probably faced something like this too, right? Something's changing. Why build a test now? Or what happens to my existing tests if it changes and I didn't know it? Well, Parasoft solves this through Change Advisor, which is our change management solution. So Change Advisor is core to the way that SOAtest works. And it's all about using AI to proactively identify and then remediate change. If change is detected during a test execution by scanning multiple service definitions, a change template is created. You see it here on the screen. And it maps the previous version of an API to the new version of the API. And it uses its best determination when linking things up. From that you can use this change template to then make minor tweaks to the AI generated matching and say, no, actually, this is the way that it's actually connected. And then you can use that template to then mass update any API tests that are associated with those service definitions. And this is a really great way to reduce the fear and uncertainty and doubt associated with building a huge library of API tests. Through a reusable change management process, you'll know immediately when change happens, and then you'll have a path forward to solve that challenge. And that frees you up to really own the solution, really move forward and build test cases with confidence. Okay, lots of words. I apologize. If you checked out, here's the takeaway. Every API testing tool that you evaluate has to have these things: ease of use and capability. I need to be able to onboard quickly, and it needs to be able to do, even complicated things like making decisions when running a test case. It needs to have optimized workflows for the things you do every single day. If you're working with a lot of data, there needs to be a test data management component in there. If you're integrating with APIs you don't understand, it needs to have an AI component. It needs to have a broad swath of supported technologies, which starts with you. You need to take an inventory of what API technologies you have, or to the best of your understanding, writing them down, and then challenging any vendor that you're interacting with. Do you support these? It needs to be able to run automated, and it would be really great if that automation wasn't an extra cost way beyond the normal usage of the tool. Running tests in an automated way is par for the course. So I would encourage you to challenge that. And management and maintenance capabilities. But to really maximize your efficiency, you need that rapid test creation. AI powered if possible. You need it to be able to have an extensibility framework that allows you to not only have the supported technologies now, but have an easy way to snap in new technologies. It needs to have broadly accessible architecture, cloud, desktop, command line, build system, doesn't matter. It should all just work. And then it has to have a change management process, because without that, your solution will run away from you. Okay, so back to the eye chart. Parasoft SOAtest is a leading industry API testing solution. Parasoft's been around for over 35 years. We've really been focusing on test automation specifically. It's a solution that checks all the boxes. So if you are looking to enter a tool into your evaluation process, I highly encourage you take a look at SOAtest. And so with that, I'd like to pop over and see if you have any questions. I'm going to put my headset on here too, just in case. Okay, lots of questions here. So let's start with, okay, first question here. What about performance testing? All right, great question. So earlier in the presentation, I was calling to the fact that an important aspect of this whole journey is in being able to get an inventory of the APIs that you have. And you can do that as a manual process or use a mediation layer. Or you could use technology like AI to convert and observe the manual operations against the application to get an inventory of those APIs. Once you have those and you build the API tests for those, you want to choose a tool that will use those API tests as performance tests. There's a couple of reasons. One, you've already done all the work. You've already stitched together all the correlations. These are the things that become really difficult in performance testing is well, I sign into the application, I get a CSRF token, and I need that to carry through, but I need to parameterize that in all the different test steps. By using the API test, you've already negotiated that. You can then run those as performance tests. In the Parasoft solution, any API test that you create, it can be run as a performance test. Whether it's something that you've grabbed from the UI, whether it's something you've directly negotiated from a front-end API, and even if it's an API test that you have against a back-end service or a database or something like that. And so, yeah, you incorporate those into your testing process. And then I see a couple of questions about CI/CD, so I'll get specifically to that. But you run those performance tests as a part of your continuous process, as a post-commit trigger. And then use the results from those embedded in your functional testing results to then gate your decision going forward. So look for a solution that just has performance testing embedded. I like this question. Can you give us an example of a client that was successful with API testing, and then an example of one that was not? It's really, really good question. Thank you, whoever asked that. Successful with API testing, yeah. So I don't know why, the one that just immediately came to my mind was a retail organization that we were working with that had API testing, but they wanted to understand how they were doing, like how much API testing they were doing. Were they doing comprehensive enough? Was it satisfying? Finding the defects, but also could we report to management that the amount of information I'm giving away the punchline here, but the amount of coverage that we were getting was enough. And what was really interesting about this organization was that they took the approach of saying, let's use a combination of the requirements and the coverage. And they had this email mailing list that was like the I'm angry mailing list. And what it basically said was some system went out. It was in this area. Yeah, this is blocking my work. So use those three pieces of information to create like a three-dimensional matrix to determine exactly where to prioritize the efforts. And they started that way. So it wasn't like project by project or release by release or even user story driven. It was priority based. It was risk based of their own invention. And they were super successful with the API testing rollout because they were solving the big problems up front. They said, this is a hot spot. Let's create a whole bunch of API tests around this area. We'll know we're done when the requirements are covered and that we have a sufficient number of code coverage, which based on accessible code to the APIs was, I think they targeted 70%. They added those two pieces of information in, and just defects in production they just started going down. And it was because of what I said earlier in this presentation. A lot of the front-end stuff is not front-end stuff, it's API stuff. So they were really successful. Now, the one that was not successful, the one that immediately comes to mind was an organization that took a strictly sort of unit-based approach to API testing. They said, we have service definitions. And so we're just going to consume those service definitions. For each API in that, we're going to have a positive case and a negative case. We're just going to run those, and we're just going to create a whole bunch of tests that way. Sounds really good in principle. The problem was that it didn't take into account undocumented APIs, and it didn't take into account API sequences. And I remember very specifically, one thing that happened was that they had validated 2 specific APIs that were actually in the same service definition. I mean, it was like a ticketing system or something. And they felt great, and they got green lights, and they run that all the time. And then they deployed it into production, and it exploded. What had happened was that one of the services response timestamp was written in a different format than what the next service was expecting. Now, here's what happened. The service definitions schema for the response said it should look like this, and the schema for the request for this other service said it should look like this. What ended up happening was that they, because those tests weren't linked to each other, it wasn't a scenario, they were always sending and receiving the different formats. And that's a really hard thing to catch. But ultimately, by running those, by observing traffic, they were able to then assess that that's actually what happened. So I guess they weren't necessarily unsuccessful, but it was the wrong approach. The approach is identify the user stories, identify the priorities, and approach it that way. Don't just blindly go through service definitions and create tests. Okay. Don't API tests break if developers change something? Yes, 100%. Further exacerbating that problem is this concept that versions have to exist for APIs. You have a UI, and we decide that we want to change something. You abandon the old AI in the new release, and this is the new version. And if somebody wants to use the old AI, tough, right? Doesn't exist anymore. It's the new version. Same thing with the code. The thing that persists are the APIs. We, by contract, have to continue to have versions of APIs available going back, all the way to the beginning. We can make a business decision to deprecate certain ones, but in most cases, large organizations don't, because partners build services against those versions, and you can't just get rid of them. You provide, migration paths forward. So absolutely, the API tests will break if the developer changes something. That's why I was focusing in that one section around change management. That's gonna, I think, in my experience, working with customers, represent a good 40% of your time. It says you're gonna come in the morning, you're gonna look at your results, and you're gonna say, okay, this test failed, this test failed, this test failed. You categorize them. And what you will find is that a large number of those tests, in a lot of cases, were due to application change. The test is fine. It's just that it's not using, like the service changed. And so that's why the solutions like Change Advisor and version mapping are so important, because the workflow would be totally different. You'd come in the morning and you would see that, something broke. And then you'd get this is what happened. It changed. There's a new element that showed up. This other element split into 2, right? So you need to update your test. A better scenario would be as if you found that the night before you left, because you proactively scanned the service definition. So yeah, when choosing a solution, you really want to look for something like that. Is this Parasoft test able to do, is this Parasoft test suite able to do testing of embedded products? i.e. .NET, not .NET or web-based stuff? Absolutely. I would encourage you to go to parasoft.com. There are 2 sides of the Parasoft solution set. The functional IT enterprise testing side, which incorporates all the things that we're talking about today. And then there's an entire embedded side. Because these things are becoming more and more important. Actually, it's it's where Parasoft started, was this embedded on target, actual testing. So yes. Is there a possibility of false positive or is there a possibility of false positive / false negative results? And if so, when and why would this happen? So I create an API test. I have an automated assertion. It says that according to the user story, it should be doing this with these particular APIs, and this should be my end result. Now, the first thing that comes to mind is this notion of a false positive in microservices. Because microservices are event-driven, there's this concept of fire and forget. And so in many cases, you may enter into the events. They fire off the ones that they want. They send asynchronous calls to other services that are supposed to do things, but they don't actually verify that those things happened. And then at the end result, you get something. But what might not happen is a secondary or tertiary system down the line getting updated or something like that. That would be a false positive, because in that case, your test is saying, hey, everything's good, but it's not actually good. And so the way that you remediate that is by isolation and targeting. So in addition to running the sequences that you expect, you want to take an inventory of all the available APIs or interfaces, and then run those as individual tests, like that first company I was talking about did, but incorporate them with your sequences. So that in a situation like that, you would say, okay, I expect that these things should happen. Okay, and that should be the end result. And I look down here and I grab something off of a queue and I validate its contents. I also, at the same time, send something directly to those back-end services and then look for the queues that they're supposed to update. Powerful tools to think about in this sort of concept are service virtualization, because service virtualization, A, can stub out those secondary and tertiary interfaces so that you can focus on the individual use case and then make sure that your virtual service is receiving the appropriate information, but also monitoring. So interwoven into good API tests that involve things like microservices should be a monitor. In Parasoft, we just have a monitor tool, and you just plug into your JMS or your Amazon SQS or SNS system, and as events are flowing, you're validating those and saying, oh, it did transform as it went from this service to the other one. And in that case, you're making an asynchronous process synchronously validated. Hope I answered that question. Any plans for Parasoft to provide a SaaS solution, accessing it through the browser? Yeah, absolutely. Right now, you could go to Amazon Azure Marketplace, or you could go to Amazon EC2, and you could grab our pre-built images, and those will just spin up. And you can either bring your own license or license them through Amazon or Azure, and then you'll have access to that individual purely cloud-based image. Had that for a while. Also, we have a Docker container, which allows you to build your own if you wanted to, secure something in Azure. Can you show that slide again? Sure. Let me show this slide with the links. We'll just go back to this. Got a kind of got 30 seconds here. Couple pieces here that I think were important. One is the topic of conversation that I had was in the left-hand corner there. It's a whole white paper on choosing the right solution, and then some other things so you can learn some of these other pieces. And with that, I'm going to go ahead and wrap it up. Thank you, everybody, for your questions. Thank you for attending today, and I hope you have a great day. Happy testing.